Okay, we're back live. Hi. Lots of good news today, man. Today's just been a good day for Puffer. Had a productive meeting earlier, got some stuff merged. Spencer found a bug in the place that I expected that there would be a bug, so I get to be smug about that. And GPU drive's gonna be working now. All I really gotta do is a little bit of work on the experience buffer, and we should be pretty solid. We should be pretty solid with the latest version. So all I really wanted to do right now main thing at least, let's go back to this sketch. I think we figured out good enough, realistically quite good solutions for everything except collecting experience on environments with masking, which is kind of the same as like collecting experience on multi-agent environments where the agents can die. And we don't have any environments right now where that is mandatory, but we do have some where that is an option, and we would like to be able to train in that setting. So, yeah, I think I want to like figure out what we do about that, right? And it's kind of sketchy. It is kind of sketchy. So before I could guarantee the batch sizes would all be the same size, and now I can't. This seems pretty bad. There's not really a great way around masking either, around this thing. I mean, the fundamental concept here, I'm going to be like thinking about this and like exploring a bunch of technical things, but the fundamental concept is you just get data that looks like this, right? So it doesn't all match up. And that doesn't fit cleanly into an experience buffer. I'm trying to think realistically how often this happens anyways. It really only happens in like elimination style games, right? Like I had this issue in Neural MMO because it was a battle royale. But like MMOs aren't really battle royale, so I just made it not a battle royale. If you have really long episodes, it shouldn't matter that much. How's it currently handled by Puffer? Does it completely skip observations? Well, in the current 2.0 branch, what is this? First time watching? This is reinforcement learning dev. I'm a researcher. I run Puffer.ai. These are all ultra high performance games that we've implemented that you can watch AIs that have been trained to play these directly in your browser. They're playing it directly in your browser. You can hold, what is it, Shift, I believe, and you can take over and play the games. Some of them are simple, some of them are complex. But yeah, this is kind of just, the vibe around here is just watch research get done in real time. And then hopefully the streams convince some of the people watching to also contribute, because it's all open source. And many of our best contributors just were people who kind of saw the content and saw the stuff and started building things. What I'm doing right now is I'm attempting to solve a technical problem in the design of how we process data as it comes in for training. So Pepper, what we were doing in 2.0 is we were collecting all the data to a flat buffer. So we just record it as it comes in, out of order. We record the indices of that data. And then right before we need to train on it, we sort all the data by the indices, so we get the like segments for each agent next to each other, and then we just reshaped it. So, data could cross boundaries. It could be that, you get the end of one segment and then the start of the next segment in the same batch. But it works cleanly, and you just don't add data to this buffer that's masked. We can't really do that now because what we're doing, we're collecting stuff by segment so that we don't cross boundaries here. And as a result of that, I can't really see a clean way of handling masking. It's a little tricky. Like, the issue is that we're filling up this buffer. I guess the right question to ask is, what do we do when an agent dies? Like, fundamentally, what options do we have when an agent dies, right? So we're getting data like this, it's all nice, data's here, and then this one just dies. Hell yeah, I'm sold, forking it now. Awesome. It's kind of, the cool thing about reinforcement learning, at least the way we're doing it, is you can kind of just jam low-level game development and help revolutionize a branch of science at the same time. And like, you can do it without that much compute as well. Let me give you one really cool example. So this is Neural MMO 3. This is a follow-up to my PhD thesis. And this is like this big open world MMO environment. There's like a market. You can sell and buy stuff on a global market. Like, there's all sorts of complexity to this thing. This thing runs at 1.5 million steps per second per core. So this thing runs like literally 1 million times real time. And we can train on one GPU in like 3 days. We can train on 2,000 years worth of gameplay, which is pretty cool. And then you can run the trained model on like one CPU core easily. So yeah, this is what I'm trying to do, right? I'm trying to revolutionize this area of AI. I'm really trying to make stuff clean, fast, and simple. I spent my whole PhD working on large-scale multi-agent learning in this space, and now I'm sort of turning to try to like make it practical, make all the infrastructure fast and simple, and make it way more broadly applicable to a ton of different things. Sometimes that involves doing a bunch of like fun programming on stream. Sometimes it involves stuff like this where I kind of just have to think about data structures for a couple hours. Okay, fundamentally, the issue with this data structure here, right? The issue is that I plan for these to get longer. Pepper here from Twitch, just switched to YouTube. Hey, Pepper. Yeah, you're, I mean, the guy has so many different names. Where did he go? You're Weston's friend, right? Yeah, this is going to be a problem. Like, we can't keep it as is, right? We can't have our data buffers look like this, where this all gets wasted, because what always ends up happening in like elimination style games is that they're just two players at the end for a really long time. I mean, this has got to be applicable outside of just like games as well. There've got to be environments that I'm going to run into where like this is going to be an issue. I'm just trying to think if there's like a decent fix. I will take, if it just does a little bit of padding and I like lose a little bit of data, I'm fine with that. It just can't be this. But it's tricky because like you have to reuse this index then somehow, right? You have to like put data from another agent here or something. Okay, here, this is kind of complicated, but like in theory, right? If I just had all the free indices, so this is like, we have like one index here, these are like active, and this is going to start off like 0, 1, say 10, 24 agents. Okay, and then we have free. And say it's like 8192. Impulse Wars trained fine on box 2. Also alternated between 145 and 230 SPS. PR should be ready. Awesome. Let me finish these thoughts and then I'll merge that. Also, the profiling I don't think is accurate on the latest dev. I have to fix that today as well. Let me see if I can figure this out first. Because I think I might have, I don't even necessarily want to implement this now. I just want to know that I have a way of doing this before I lock in the new experience buffer design. Okay, like if an agent dies, right? Can't I just technically, let's say agent 2 dies. Can I not just append it? Or even better, can I not just like prepend it? Would that work? I think so. Like this is technically a possibility because then when you need more free indices, you just grab them from here. Your message posted twice, Captain. Okay, but the other question here is actually like, how likely is this scenario that we end up with this? Like, are we realistically going to want to collect more than like 128? Because typically in Puffer, we run a lot of parallel environments for compute efficiency. So like 1024 environments times 128, that's already a million, right? That's already a million. No, I'm dumb. That's 120K, I'm stupid. Okay, but we run more than 1024 environments. Usually we run like 4096, so that's 500K. So like, there's not going to be a point in backpropping more than 120. There's just no way with current architectures it matters. The only benefit is longer rollouts let you compute advantage over longer horizons. How confident am I that we're going to need long horizon advantage computation longer term? On one hand, like fundamentally, I'm not confident that you have to compute long trajectories to learn stuff. But that's going to be dependent on a bunch of future research. And so far, it has seemed really important for what we've been doing. So we'll call that a toss-up. I think ultimately the conclusion here is that we don't deal with masking right now. We don't have any active projects that require masking, but we have a way to steer if we do end up requiring masking. And also technically, could I implement this in CUDA? I'm pretty confident I could implement this operation very efficiently in CUDA if I had to. Yeah, because you don't actually need to append stuff. You could have a fixed size list, and you could just like overwrite existing values. Okay, I'm confident that I could do this efficiently if I had to down the line. Have you thought about trying to perform transfer learning from one of the games, say search and rescue, with a multimodal approach, if possible, that runs 3D? So here's the issue with that type of thing. I just talked with a company that's doing cool work in that space now. The issue with like trying to do transfer, it doesn't work like train on one environment and then transfer to something totally different. The only way that works, and the only way that that's been demonstrated to work in other areas of AI, is train on a ton of tasks and then transfer to something kind of similar or kind of in that space. That is just a much larger scale of research. Like fundamentally, yes, we could technically do it, but now we're talking about needing hundreds of games and probably needing at least hundreds of GPUs, like for these runs. Whereas for what we're doing, we can still get our fundamental research done on all these methods. We can train on like billions or tens or hundreds of billions of steps, and we can do it on like one GPU per run. So we're doing pretty darn efficient research for compute now. That type of like generalization stuff is out there. Like, yeah, we're interested in it, but not at present scale. Is this problem related to just the sampling of the experience buffer? Or are you talking about the buffer for PufferLib? Just the sampling of the experience buffer. I technically have a very large improvement to make on our vectorization by integrating, by having the option to use torch tensors in the vectorization itself. But it's going to be way easier for me to implement that thing, and it's going to be way simpler if I just wait until Python has good threading. And probably if by 3.14 they still don't have good threading, I'm just going to do it in C, is most likely what's going to happen. But if Python actually gets threading to work correctly, then we will be able to do that very, very nicely. We'll be able to have like very, very nice improved vectorization with that. At least I think we should be able to. You need to be able to have, you need to basically be able to share slices of torch tensors with different workers. And because those are on different processes right now, it breaks. But if they were to be in on different threads, it should work. Welcome, YouTube folks. Okay, so I think that the conclusion of all of this is that this is probably still a good buffer design. Realistically, this covers like 95% of the cases that we want to learn on. It does it way better than the previous version of the code. There's a 5% of cases that the previous code covered that this just doesn't cover at all. But if we really had to, we have an efficient way of handling that. I think that's the conclusion from this section, which is good. That's a good outcome. Anything from Spencer here? Expert trajectories on the first 256 have 7% collision and 2% off-road. So I may need to prune the data set. Huh. Interesting. Probably their data set's just noisy. Okay. So I think that what we're going to do now, 2:30, I think I'm going to work on the experience buffer code a little bit. I'm not going to handle masking, but I'm going to see if I can get all the other edge cases out so that this thing generally behaves sanely. Actually, there is one other problem that we need to solve, I believe, first, which is quite a bit simpler. There's been this weird indexing bug that I just need to think through. Right now, the way that we store data, like, our most common setup is something like this. So you got like 1024 rows, 1024 rows. we can have offset infos for each dimension that helps create an original tensor. But then you're training on, wait, we can have offset infos. So then you're training on you're training on padding, right, Tago? You ideally don't want to train on padding because it's a waste of compute resources. Like I had this issue in my PhD a whole bunch where you would get like 5% data density, so you're throwing away 95% of your compute if you train on the padding, even if you mask it. So the goal is to create dense data, not to pad. And in 95% of cases, it works as is. And in 5% of cases, the thing that I discussed before should allow you to create dense data, where you're basically, like when you run out on one axis or whatever, when you get like to the end of an agent lifespan, you're going to use the next piece of that segment for another agent. And the indexing I had there should work. Okay. So the way that this needs to work is you put data into each of these buffers. And what I was doing right now is I was having a free index. So I was saying how many rows do you have left that are free? And what was happening is if you had exactly like the exact number of agents as you had data rows, then you have no more indices free. So even though you have spare room in this buffer, it wasn't picking it up. So I think what I have to do is something based on episode lengths. If I make a hard assumption that we're always going to fill in the correct order, I think I can do this, and I can just add a check to make sure I don't screw this up. So I think what I do is I do like num like full rows. And then when you get to the end, I increment this. That way, I'm not looking for extra rows, I'm looking for how many are full. And I didn't want to do this before because of the masking thing, but I think we're actually fine with the way that this is. Yeah, this should be 100% fine. Okay. That wasn't that hard. I guess I was just tired before or whatever. Let's implement this very, very carefully because this is the type of thing where you can introduce large bugs. Check one other thing in Discord. All right. What is the current state of the code? That's fine. So we still need this here. We'll put a warning on that. This has to be like full rows. How about full rows is less than on policy rows? Data.full rows. It doesn't even need to be in data, does it? We'll do this for now. So what I was doing right now is I was incrementing this like free index. You do need a free index, don't you? I could also do just increment full rows. But this is the same freaking code, isn't it? No, this is not the same code because they start at different values. These start at different values. Okay. That was the thing that I couldn't figure out before. You need to count both the free, what index you're going to fill next, and you need to count how many rows you have full. Those are different pieces of information. Okay, there's breakout. Trains. Looks good. We'll like make sure a couple environments run, and then we will do captain's PR. And then with the next couple hours afterwards, assuming that that goes well, we will continue to clean up this code a bit. "50-second breakout solve." That is actually faster than before as well. So I think we were throwing away some data or something before. We must have been like throwing away some data. Let's also just add a decent warning while we're here. That's decent. And neural MMO trains, 400K with the big model. Pretty decent. We're happy. Make sure I didn't screw it up with that warning. Yeah, that's good. Cool. Okay, that's a clean fix. Let's get this merge going. He said that this was ready, right? 18,000 lines. Holy. You must have committed something you shouldn't have committed, right? 18,000 lines, man. Yeah, let me just merge that real quick. Hang on. Clang format. I don't mind dirty merging this, but holy hell, man. I know the env is like 8K. Where's the other 10K coming from? To be determined whether or not we accept CMake. And we'll either accept that, though, or find something better. Your env will get merged. I'm like waiting for the joke file that's like 10,000 lines of ha ha ha. Okay, well, these we've reviewed already. We did like a full review of this environment. It took like 2 or 3 days on stream. This is most of it. Oh, you included... Alright. You included source files for some dependencies, it seems. Probably there's like another one of these. Yeah, DL Malik, there you go. So it's big because of... Not a fan of the vendor depths like this. Makes it annoying for us to like keep track of our code base size and stuff. Does anybody know how GitHub tracks like line counts and stats? Can I put stuff in like extern or something and have it not count it? If we're gonna do that. Shaders, we reviewed these as well. We actually will get to run this env in a few minutes. If I can get this integrated and set up, it's a really cool environment. It's like really, really a cool environment. All credit to Captain for the code on this. I helped with some of the front end for it. Okay, so we're gonna approve this. Ping this beast now. Not a fan of CMake. We'll see if I can find an alternative. Let's see. Fan of dependency. Files gonna be beast. It's extern or something. But this some doesn't mess up. Stats, etc. We will do this. Workflow requires approval from a maintainer. Question? Yeah, no, it doesn't require. It's just getting merged. Okay. Let's see if we can get this to run. I want to run the renderer for this. It's a really cool end. Very happy to have this in Puffer in any state. Yeah, there it is. 18,000 freaking lines. So if we ignore like was it 10,000 lines of dependencies? Was it 10,000? Not quite. It's like 8,000 lines. So it's like a 10K line PR. That is probably half or a third of the size of the Puffer C code base. Probably like a third the size of all of Puffer. So this is a very big N. Did Captain tell me how to compile it? CMake. Is there a separate setup or something? Oh, there's a toml. Maybe this will work. So yeah, the thing that's tricky on the infrastructure side of this is like, this has a couple extra dependencies that are annoying to build and link. So Captain just used CMake for it. I really do not like CMake. I really hope that we can find a way to just like have a really simple build script that just does this and cut out the extra dependency and stuff, but we will see. I figured we will merge it for now so that we can run experiments on it. I kind of want to have all the new M's checked into Puffer. And that also lets me iterate on the models a little bit to help out to help them out on this. Okay, so impulse wars. Runs. It does not render. Okay. I guess you have to put render equals true in the end. Yeah. Holy. That doesn't seem to be the intended behavior. Captain. I imagine that this is because it has and we can hack it for now. There we are. So this is just the built-in like scripted opponent versus a random agent, random neural net. Rendering at, I don't know. This is not real time. This is faster than real time. But yeah, this looks sweet. We gotta fix resolution. We gotta fix like render args and stuff, but this is sweet. This is gonna be so cool to have in Puffer. This is like a full game. Okay. I'm gonna rename it to Puffer Impulse Wars. And we're gonna see what holy. Takes a second to compile. Shenanigans. I kind of want to disable this annoying compile stuff, to be honest. I don't think it makes anything much faster. It just makes dev more annoying. It's dead. Is it? Are we good now? Okay, refresh. Internet blip, I guess, or restream server blip. So I did find something. Hi, are you building a game using reinforcement learning? We're building a large number of games and using reinforcement learning on them. They're all on Puffer.ai, at least the ones so far. We have more in development. Everything from like Breakout up to more complicated and interesting things like this mini MMO. We got lots of fun stuff in here. You can join the Discord to get involved with the development of it if you're interested. Okay, I think the stream is back. We had a little bit of a server bug. I dropped a ton of frames, but should be good now. Yeah, Captain, it dropped like a ton of frames. It was just the restream servers being bugged. And I might have to get a different provider for that. Their servers screw up once in a while. So I found this. Replacement equals false. Discord link? Absolutely. It's very easy to remember. Most of our contributors came in with 0 RL experience as well, and are now contributing very, very productively. So I don't know your background, but if you can code, you're probably good. Replacement false. This is sketchy to me. It should be replacement true, right? Has it always been this way? Yeah, look, the default in Torch says true. So if I just do multinomial, what happens? It should be faster with replacement, right? You would think so. Oh, you know what? Hang on. Let me get one more data point on this and then I have an idea. Okay. So this isn't faster on its own, but what about if I do both? Because it could be that the concatenated one still has the replacement overhead. Did you see the small changes I made to demo.py? I did not. I'm trying to fix the multinomial sampling thing at the moment for you. I'm actually very surprised that doesn't fix it. Okay, well, what else does this do? So this calls multinomial, and then it calls reshape, and that's it. I mean, that's the whole operation then. And then log prob here. We should probably just get the torch profiler out or something, right? Torch profiler is such a pain. But I think that's probably what we have to do. Was able to figure out, yeah, it's just kind of annoying. It's hard to read. Yeah, I know. That's why I don't like it. Can we do something like this real quick or no? If I just do like... If we just do this... Who did this? Who did time total? Let's see if this does anything on its own. Okay. So sample logits total is 200 microseconds. Multinomial. This seems pretty evenly distributed, doesn't it? Wait. Okay, 30% in multinomial, 30% in sum, gather, copy. That seems pretty evenly distributed to me. But you can see here it's CPU time, isn't it? Oh, here it is. It is the multinomial. Multinomial taking a whole bunch of time. It's all CPU time. Okay. So do we need to look at the multinomial code then? Underscore categorical dot sample. Oh, and then there's a scatter inside of it. Okay. What is underscore categorical? Categorical. Didn't I just read the categorical source code and see it had multinomial in it? Or am I going crazy? Wait. What? Categorical calls multinomial, and multinomial makes a categorical? We're not happy with that. Is there a way to find where the source is for this? Okay, get out of here, bot. It seems like it's dot multinomial. It seems like it calls this. So then I don't understand how these things fit together. Because this makes a categorical. And then this does the sample on this. Underscore multinomial. So wait, this is a constraint that has a check that doesn't do anything. How does this make any sense? So multinomial, right? We get to here. Then this makes a categorical. And then this calls this multinomial. Which takes prob sample shape. It's not this, right? Is it this? This is Onyx. Could be this. But I mean, this is defined, unless this import gets overridden somehow. Where is this? Torch dot multinomial. It's gotta be this, right? There's an underscore in it here. Do these import star? Okay, this init file is not going to be particularly useful. So I can't tell what the hell it's calling to do this multinomial. Was there A10 multinomial in this trace? Didn't I just do this? Hang on. Where did I put this? Here it is. So A10 multinomial, right? Does this mean that the, hang on, if I see the overhead in A10 multinomial, this is 1.7 ms. And then this says that I have like 300 ms, 300 microseconds of that in these ops. So then where's the rest of it? The actual multinomial isn't that slow. It's probably the wrapper glue, right? Do we even need this? Is there a simpler way of doing this? Num samples indices are sampled from the multinomial. We're only ever going to sample one. Right? This is a generalization of this is literally just a prob sample. Weird. Okay, so you make a categorical and it calls multinomial, and then it can potentially do more than one sample, I guess. And like, it's probably this thing, because this is A10 multinomial. Log of input. Utils graph context. And then it's by name. I'm very confused if this is not just a prob sample. Is this doing anything other than just like sampling based on prob and giving you log prob returned? Multinomial logits to probs. You can give this thing logits to start with. But I think you can do even better than that. We're gonna ask dumb questions and get some dumb answers. PyTorch, multinomial sample, doing anything other than just giving it a number based on the provided probs with utils like log prob that this gives. Well, I guess that's all it is. Okay, so like this goes through a whole bunch of garbage. Okay, I don't actually know. I don't know about this. Is this different? The input prob stiffs. Yeah, so it's not doing anything. It's slow. Simpler. Sample goes through fewer. There's some basic GPU. I'm just looking if there's like a lower level function for this. No, not categorical. Add gumble noise to log probs. Does that work? I bet. Does this work? That's different, bet. Or it should be different. Maybe it's the same? That might actually be the same. I remember that from a totally different context from like years ago. Yeah, the multinomial's slow. Yeah, this is different. This is so that you can compute gradients. So I do remember this correctly. So it is actually interesting to think about that. I haven't thought about that in a while, so thanks. In small, what do you mean? No, it's the function is screwy. Their function has like 10 layers of bullshit you don't need. As always, fang code. Oh, this is so funny. This is like I was interning under this guy as a high school student about in this time period. That's funny as hell. This is from 2018, man. Is it relevant? This is like super old, right? And where did I just put your link? Funny to see your time jump 15 minutes. Man, it's restream what you want me to do. Yeah, this isn't what we want either. I have install instructions in PR for building. You weren't using the latest version. What do you mean I wasn't using the latest version? What? The PR that I merged wasn't the latest version? Pip install -e dot doesn't do it from the Impulse Wars directory. Oh. Okay. Well, I pip installed from your directory with your pipe, like your toml. This is so silly. Isn't it just like argmin of a cum sum or something? I have DSA algorithm, I don't know nothing. Should probably study. That's what I would suggest. I literally had to look that up like last week or whatever, because it's just domain, it's data structures and algorithms. It's just a standard FANG annoying, like solve tricky impractical questions live. All right, with the advertising bet. Shouldn't it just be like, shouldn't it just be internally doing like argmin of rand less than cum sum? Can I just do this? Yeah, I did fix that. I might have rebroken it, we'll see, but fully compiles the eval pass. And then the backward is mostly fast because cuDNN. That's been a thing for a while, but so this actually does noise on GPU. So hang on, we should be able to do something with this then, if we're a little clever, right? Torch dot, that's not it, right? Let's see if this does anything. It would be pretty sad if that did do something. But it's possible. So the idea here is we just bypass all the multinomial shenanigans. Argument CUDA is not implemented for bool. So you can do torch.sum, right? Is this running the same function? What is this, 5? I guess 17. What is the size and shape? It's categorical. Yeah, it's just, they just give you some probabilities, man, and it's like, for some reason something is slow. Okay, we still have 40% time in forward pass. Not ideal. Goal for today? Mostly cleaning up the experience buffer, improving performance on that, and Captain just PR'd this like 10,000 line environment that's currently bottlenecked by action sampling, plus I've had a couple other requests for that. So I'm spending a little bit of time seeing if I can improve that right now. And then if I have time after that, I will probably go back to cleaning up the experience buffer, getting some new experiments running, and things like that. You need to fix the panel and profiling. That is true. I don't know. We can answer whatever he wants. It's a free country. Okay, so now I see softmax. Softmax in here is taking up the time. Where the heck should softmax be getting called? What should be calling softmax here? What is this? I just like torch profile shenanigans. It's one sample per element. Does logprob call broadcast tensors and then gather logit entropy Okay, if I do this, is this included? Okay, so there's still softmax, logits to props. Oh, logits to props. So when you call multinomial, does it do this internally? Okay, this does do a softmax. Which you have to do, right? You have to do a softmax for this? So that's now what's taking up the time. And A10 softmax is mostly on the, it is on the CPU here. We're deep in PyTorch code. Not that deep, to be fair. Barely getting to the C++. I want to see if this calls logits to probs or something. So when you do this, because here you can give it logits, right? Yeah, you're allowed to give this thing logits, and then it just saves this categorical, and then categorical does, it norms it or gives it logits, and this is self-param, and then underscore init or whatever. So underscore init on distribution, does this have stuff? This doesn't seem to do anything. I don't see any normalization happening there. So you do this thing, right? Logits minus this. That gives logits, and then... Oh yeah, probs is logits to probs, cool. So logits to probs. There you go. It just does softmax. So logits to probs on, so it normalizes and then does this. Wait, log sum x. Can we cut that down? Log sum of x of logits. And then the softmax does this. Wait. Isn't this the same? Sum x logits. We still need the probs, right? Because we need log probs. You just linked me the same distribution, bet. Well, but the thing is, it's not even like really... Okay, this whole thing is like massively written out to be more confusing than this is. Look, this is literally all that's happening, okay? This is all the math that you need. You don't need to know anything about stats or distributions or anything. P0, P1, P2, P3. These are numbers that sum to 1, okay? Then, let's say this is like 0.1, this is like 0.2, this is like 0.3, and this is like 0.4. All right, these sum to 1. So what this is going to do is it generates a random number. Let's say it's 0.45, and then it goes, is this number bigger than this? No. Okay, let's add this to the sum. Is the sum of these two bigger? No, it's not. Okay, let's keep going. Is this one bigger? If I add this one? Yes, it is. So this is the best one. So 0, 1, 2, and it's going to return index 2. That's the entire operation. There's additional normalization and stuff, but that's the entire operation. So this is not really complicated. Yeah, there is some like, the thing is you don't get probabilities, you get logits, which is like, you have to then transform those into probs. and usually you throw that through a softmax for numerical stability. But like conceptually, you don't need to know anything about advanced prob or stats or anything. Like it's really, really basic. It's just there are 10 layers of code for something that is very simple. So that's all I have to figure out how to get around. Like this here this is for numerical stability, and then the softmax is technically also for numerical stability. So like, let me see what quantities we need. Do we ever need probs? So we need log prob and entropy. So we norm the logits. What's log prob do? This is just a broadcast. Okay, so this one doesn't make a ton of sense to me. Let me just like paste this and ask some questions here. I'm confused. I'm very confused on this. Hey YouTube folks, welcome. We're currently doing numerical optimizations on our RL inference path, specifically the action sampling. Gotta make PufferLib go fast. Actually, let's just copy all this. Cumulative distribution and a bind. Isn't that just like incredibly stupid? Wait, is that actually how things... Why the hell would you binary search it? When you're computing the cumulative distribution, you should just be able to like get the index in the process of computing the CDF, or the cumulative distribution, not CDF. Like I showed you, right? You don't need to binary search it. You only need to like binary search it if you have a really long array and like you're doing this the cum sum first. Well, because in this case you literally get the answer in the process of doing the cumulative sum, right? So technically, yes, you can improve over the one that I wrote, but you'd have to write a kernel. I just did cumulative sum. But the thing is, we still have we still have the softmax, and the softmax is slow. So now my thing is fast, but there's still the softmax sample, the softmax. So I'm trying to see if we can combine some operations. Is Gumbo Max stable? Hang on, what is this? Oh, that's interesting. Try this. Yeah, well, Torch doesn't. Let me see if this does anything. And then we replace this where the multinomial is. So we just do I guess it's just going to be like Bell. And then you still need norm logits, but this avoids softmax maybe. Let's see. I guess this makes sense because, like, the action distribution doesn't have to be differentiable, right? Okay, so now we can see what's wrong with this still. Random. So now the noise is now the bottleneck. I have thoughts. Allocate a giant ass class. CDFS lookup table. Generate a bunch of random numbers. Make your own CUDA. Your own CUDA that avoids all the stupid size checks. It's really weird how like every single thing I've tried is about the same speed. Like now it's bottlenecked by a random number gen, it seems. It's also all CPU bottlenecked, which is weird. Ideally, eager mode should also be fast, Captain. So this can be like ooh, awesome. Check that shortly. This random noise is... You always need to regenerate the noise, right? Nah, there's no way that's gonna be good. I mean, we got it right. Where is it? Right here, right? Rand likes 800. It's a random number per action option, Captain. Why is the CPU time that high? Does this not like generate the noise on GPU? PyTorch make noise on GPU. Okay. This is something. Yeah, I don't know what that's doing. Uh, How about if we can cache the tensor if not the noise, right? So we don't have to keep remaking it. Maybe that helps. Like, how about that? So, storage. Dot zeros, like, okay. And then make sure you plot the R. I'm not caching the RNG, I'm just caching the storage tensor, right? Yeah, so now uniform is slow, huh? I'm kind of tempted to bet, but I don't really think you can. You know, that guy, should this be slow? Like, RNG shouldn't be slow, right? Is this like some dumb thing where you have to get it from a certain stream or something, so like it's not parallelizable? Bunch of internal checks. Technically, it could be that. It is CPU time. Do they have like, are they doing checks per element or something, that guy? Welcome, Peanut. Size checks should not account for this. They would have to be checking every element or something. Hang on, let me just check for ghosts real quick. Is that faster, or did I just get lucky? No, I just got lucky. Okay. See ya, man. Good luck. Make sure you have your work saved. Boxes are getting shipped. Or carried, or whatever. Potentially. What about tweaking some consoles? What? This is super irritating. Well, I shouldn't rely on this. I want to do the end-to-end speed. See if that has changed anything, because there's a ton of overhead in the profiler. So let's see if this has changed anything. No. Because compiling is a pain in the ass generally. And like if you want a library that only works properly in full compile mode, like use Jax. Or TinyGrad actually. If I wanted a library that only works in compile mode, I'd use TinyGrad. It's like dramatically better software. I mean, I could technically cache the noise. Let me try that real quick. Because if that doesn't work, then nothing's going to work. This is going to be somewhat tricky. I don't want to spend all day on it, but I will try something. Um, okay. There we go. Now you get to, like, the key thing here is we get to comment this out, right? Yeah, okay, so now we profile it and see what the heck it says is. I'm starting to suspect the profiler sucks. Because this doesn't make sense. Yeah, so here, now it's saying add is taking. This time. It does say this is faster. Let's do it. Let's see if this changes anything. Nope, that's what it says. It says add is taking time. No, we're not making fucking environments continuous over this bullshit. We're gonna solve the problem. I imagine this is like a combination of profiling being dumb and a few other things, like just being hazy. What's wrong with this thing? That doesn't seem right. Did I think I screwed up something here. Hang on. No? Dot stack. Dim is 0. Okay. Was very close. Okay, so that gives you 250. This is still incredibly freaking slow, right? Can't do that actually because it's these ones need to actually be backpropped through. That's still freaking slow. Try some stuff. Then you get end of bottleneck top. Yeah, it's rough. There's not much way around this then. $128 times 16. Only 2048 and quad buffered? Yeah, you can't do that. It's gotta be like 512. the end really gonna bottleneck that hard? Definitely gotta be like 512. Super obnoxious how that is, though. And then it hard bottlenecks on ends. It really shouldn't be hard bottlenecked on ends. With 16 copies. Really shouldn't have to quad buffer. Do 8. 6. Let's see about this. Okay, so now we have 45% end time. Yeah, this shouldn't be the issue. We're gonna try some stuff though. Okay, it's just the ends being slow. It's hard to get around. You get way more reasonable ratios now. Aside from the M's just being slow. So it really was just small batch training, huh? Oh, do I have this on now? 56. Is this? Yeah, it's 496. So this is the correct number of MEMS to have for training, for sure. $50. See what this does. When are you moving the boxes? Probably tomorrow. I didn't mess with this, did I? I did. Do this. Okay. See if this does anything. So it doesn't do anything? Is that the conclusion here? Oh, well, this is doing everything, right? Hang on. I mean, this action sampling stuff really doesn't seem to make a damn difference. I can definitely optimize this a bit without doing the Gumball softmax stuff, right? Like, yeah, because this thing does probs. Yeah, all these operations are just kind of sucky. Um, Let me think how we want to do this. how I want to do this. You only need the loops for multi-discrete. So what we're gonna do, what we'll do is we'll do I think there's a good way to clean this up. It's just going to take a little work. It's the same speed. Now, okay, there's some ops we can potentially save. So we get logits to probs. So think we're just redoing a ton of operations in this, right? This gets summed over both, I believe. Currently it's some, not mean. And then log prob. What did I do for log prob? We are going to get a speed up out of this today. It's going to happen. Oops. You need probs, don't you? Where is this? 433. Okay, so this oversummed. In train mode, it oversums. Okay. We actually get a trace. So why is there an extra dim? You would like to have log prop should get you a dimension. So I think that this is just wrong then. Is this not supposed to be summing 0? Lovely. Does this already fail? So this already fails. Yeah, I guess I didn't account for that now, did I? Okay, we'll debug it in CUDA, I guess. Logits to probs on. This should be normalized logit, shouldn't it? We're getting somewhere. At the very least, this will clean up the code a bit. At the best, it should be a bit faster. Once we get it to work, that is. Okay. So you can't do log of normalized probs or whatever. Let's see what the original. What did I do in the original code here? There's a log prob. This one entropy. Okay, so you take normalized logits and logits to probs of logits times logits to probs. Wait. I am doing this wrong for sure, right? Where'd my tab go? Logits times logits to probs of logits. I mean, do you have to do this clamping thing? This doesn't do any expensive ops, right? Isn't this it? Entropy, yeah. Okay, it runs. Probably not any faster, right? Code is much nicer though. So once I clean this up a little bit, right? Like, this one's fast. This other one's also fast. Probs is equal to logits to probs. We'll leave the profiling in for right now, I guess. Oh, well, it is fast now because of the different params. So I guess this is the current thing, right? This is the new code. So this is an upgrade. And then if this runs, what we'll do is we'll try the original and see if it's any faster on the original. So we have this, and then we have we've got this, so this will be quad buffered. And then hopefully with quad buffering it should be a little better. Maybe not. Doesn't seem like it. That is a little better maybe. Yeah, that is a little better, right? And then what was the original, like, param or whatever in here? I guess it was 60, no, 128. So 128 quad buffered? Yeah, 128 quad buffered. So that's going to be like very low batch size. It's better. Shaved like 20% overhead off of the forward pass. Runs pretty much the same now on any of those settings. It's not bad. Alright, now we have to make sure we didn't break everything else. What in the heck? Why is this changed? Wait, why? Captain changed some stuff. I think he left comments somewhere. Would they be in the PR maybe? Yeah, that's not cool to change that. What did you do? Comment this for now. Oh, you just added an extra arg, I see. Okay. I'll have to fix stuff so it's easier to add. We just, all policies need to take args, that's the thing. So if we just do, let's say we're not going to do this crazy random noise thing. I mean, maybe we should try it, since I spent the time. That actually kind of does make a difference. That's so annoying. It's like a 5% improvement or whatever. Pre-allocated noise stuff. Seems like it makes a small difference. I don't know, is it worth leaving that in there? Versus it's kind of sketchy is the thing. Like the alternative is to just do this. So it's like 228. Oh, hang on. I think it doesn't make a difference. Yeah, I think we're fine. Yeah. Okay. It really shouldn't. Good. Forward pass. I turn on sitting ducks. Env time. Why is env time less with sitting ducks? Is it because it's a 1v1? Like, what? Okay. And then what we do is so we do this, and now it goes from 270-ish. Yeah. It's not bad, right? Total time steps is 10 mil by default. So, not bad. I had to make sure it actually works on the other ends. So we're keeping that guy's change, but we're fixing some other shit. good to me, right? It's a 40-second solve. Pretty good. Let's make sure it works with like neural MMO3. Solid. Okay, well, how's that for a little perf improvement? We cleaned up the code and we made it a bit faster. That's decent progress, right? And then you can figure out the demo thing. Well, or I can actually, to be fair. You can just change it locally for now. Oh, I don't need the deterministic false thing. We'll test that later. Is there no way to link somebody the Let me go send this to the other person who wanted this. Okay. Neural MMO3 was good on box. Interesting. We can always get it sent in if we need. It's fine. So I've got like another half hour before dinner. Possibly longer, we'll see. I'm going to take a couple quick minutes, grab myself a drink, and then we will do a little bit more cleanup on the experience buffer, a little bit more optimization, and just generally a little bit more work on getting this into a good spot. Be right back. Okay. Uh, cool. Impulse Wars, running at a respectable speed. I guess we have this perf profile right here for us, don't we, for Neural MMO? 11% copy, 20% forward, 5 in MISC. That's pretty darn well optimized, other than the copy overhead, which is it's kind of a lot of copy overhead, actually. Now, let me check that. I'm pretty sure the D-type is right on that. Should be pretty small. Uint 8. 1700. Um, wait. How's it 1700? That seems big. Wait, what? Oh, it is 10 channels. Okay, I forgot I did that. Yeah, I'd forgotten I'd done it that way. I have this fancy bit packing stuff, but 10% overhead to not have to do that is not horrid, I suppose. So, was there anything else that I had to actually do on the experience buffer, or is it ready? I think the CPU fallback doesn't work right now on the buffer. Oops. Alright, let's fix CUDA build. Should be pretty easy. Where's this? Num steps. Okay, so this vtrace check signature I think just changed, right? So this now takes values, rewards, done, importance. VS advantages num steps horizon. Do we use that? There's no VS. Right? Oh, this is actually passed in. Okay. So rewards, dones. Where's this? Yeah, there we go. For CUDA. Vtrace check. Oh, and now we're calling it with the wrong args. Oh. And you don't pass in trace either, do you? So this is just fully dated. Vtrace check. So wait, this was the signature, right? So you pass in values, rewards, dones, importance, BS. That's it, right? And then you don't have trace, you don't need to return this. And now the other ones are going to error the exact same way, so that's easy. Importance. Trace. Yeah, so this doesn't give you trace. Oh, I see. So literally it's just the advantages. Yeah, we're gonna have to figure out how to reduce boilerplate in this thing, but not today. Today we're just gonna get this to run. So here, vtrace takes to float star. Trace gamma. And vtrace rho. VS advantages, right? Wait, what? Well, that would screw up everything. Hang on. When did that happen? Oh yeah, that would definitely break some stuff, huh? VS and advantages. So yeah, there's a lot of stuff in here. Oh, but it's only in the CPP. It's not in the CUDA, right? So this fallback was wrong. It's not like I had it wrong in here. Yeah, this is fine. Okay, I got worried for a second. That would have been a really bad bug. But if it's just in the fallback, that's not really for anything but debugging, that's fine. Like, at least it's nowhere near as bad as otherwise, right? Okay, importance. Gamma lambda. Says everything but lambda. Puff row. Puff advantage row. There's just a ton of boilerplate involved with like binding the C to CUDA and to C++. Like through PyBind with Torch. The actual logic, like the kernel's really easy. Or at least it's simple, maybe not easy. But yeah, it's a pain. Trace was not declared. Trace, yeah, this is bollocks. Values, dones. This is PS plus offset. And then this one as well. Was it values, rewards, dones, importance, yes. It's a little silly to have these giant signatures repeated everywhere. Otherwise, there really wouldn't be much code. I don't know. Maybe I'll find some way around that. But yeah, so actually the training is very, very slow now. Most likely because of this kernel. Actually, the kernel should be under MISC, shouldn't it? Oh yeah, there we go. 200K on CPU. Totally acceptable. Let's make sure I haven't broken GPU. And we'll push this. Still trains quite nicely. Trains quite nicely indeed. 11% MISC is a little bit annoying. 11% MISC is not that great. We have also profiling fixes to make at like 15 minutes probably. I'd also like to set up some runs though with the latest code version. Let me get that set up first. Hang on, let me figure this out real quick. Player. Yeah, that's pretty big. Okay, so I kind of want to try some network changes, but I actually want to have a baseline on the current version with the layer norm. So I think we're just going to let this be as is. Yeah, that's what we're going to do, and we're going to just SSH to the new box. I think I'm just going to bring both of these boxes next to me to the new facility. Because, like, I don't know, I'd like to have two personal ones. Just right there where I can get to them easily. No changes to neural MMO, at least there shouldn't be. So, oops, TMX. 2. Train. Okay. And make sure the config looks good. Change this for now because of experience buffer bug. Let's do that. Batch and mini batch are the same. And is that, hang on. So 4096 times, do 64. That actually would perform better. Yeah, I think this will do better. Let me fix that. One moment. set this new box up for what I need. Okay. This will give me the Neptune token prompt. Just I'm gonna run this like so, and then I will check the perf. If perf is low, I'm gonna go back to the older PPT horizon. But I think it should probably be good. Total agents. Oh. Right, that's why I had it. What do I think is better? I think we'll just do... Yeah, we'll do BPT Horizon 32. This will match the original curves. That should match our original curves. Pretty good. 570K. It's kind of crazy how fast, like, and well optimized Neural MMO is compared to some of our other M's. I think I can make it even faster, to be honest with you. Okay. So we now have, we should have Neptune run here with Neural MMO already getting us some score. Very nice. Probably 35 mil or whatever. So we can leave that be. Other changes and things. Profiling, maybe? Let's see if profiling seems correct. We'll just do basic division. See if it makes sense. So 1.6 mil, and then however long it takes. 1.5 mil now. 80/50 is in fact 1.6 mil. Profiling seems accurate. Good. So then if profiling is accurate, we can use it. We should be able to use it to mess with some perf numbers. Breakout has obnoxiously high copy time. Really does, doesn't it? There's not much I'm going to be able to do to get around that, though. So let's just play with stuff based on perf. Okay, this still runs 1.9. Then we do 32K. 2.7, 2.8. Does it go up from there? No, not really. 32 is kind of maxed. What about 16? 16K, is that maxed? You get a little bit of benefit out of this. And then that's with batch PPT Horizon 64. So let's do 5 to 4. 8192 perfectly. And then 32, 7. Here's a batch size of 5, 12 sequences. That should be pretty good. Let me run this again. Are there any other params that matter here? Not particularly. Now the thing is, I don't know if this is going to optimize the same. I would be surprised if this fails. We'll do a very quick just manual fiddle with learning rate, see if it still solves type of a thing. Almost. Almost. If I just delete these other things, what happens? Should be roughly on par. Oh, also these atom betas. This is kind of ridiculous if you look at it, isn't it? 2.6 mil. I'm gonna be honest, I don't really know where the extra perf came from, but like I'll take it. Okay, so that's 30 seconds, 855, which is almost a solve, not quite. Let me try linear schedule real quick. No different. What about no annealing? This I expect to break. So we pretty much have to figure out a way to get mini batch size higher on the smaller models because 2.7 million SPS is ludicrous. Interesting. You do actually need a scheduler. It doesn't matter if it's cosine or linear, which is like two very different things. So, okay. Okay, that's too big. Solved. 29 seconds. Let's put that in dev. I'll take it. I will take it. And this is default batch size, default BPT horizon. So we can delete these. It's also default numevs, numworkers, all this is default. This is default, this is default. So really the only things we've changed these two. We probably should now go and fiddle with these on other environments as well. But I'm just going to commit this. That's pretty good. pretty cool. All right. Today has been a good day. For the folks watching, I'm getting dinner. I might be back for a bit after dinner. We're gonna have to see how I'm feeling. This is a pretty solid result, though. Let's just take a quick check at this graph. This graph is also looking fine. Cool. If you're interested in my work generally, Puffer.ai. You want to help me out for free? Start the GitHub. Really helps. If you want to get involved in dev, join the Discord. It's discord.gg/puffer. Our top contributors actually mostly came in with 0 RL experience. So if you know how to program, you want to do some cool stuff, join and start writing some code with us. Other than that, you can follow me on X for more RL